This is RoboRoo. Welcome to our presentation. I'm Josh.
I'm Saul.
Kevin could not be with us today. Rest in peace. Here's our concept, as we previously saw.
It's we've got a 2 degree of freedom leg in the middle, sandwiched between two 1 degree of freedom legs on either end.
6 legs total.
Here's a quick and dirty rendering of what this would look like. The
body is still in progress,
but the legs geometry themselves is pretty fixed. It's just their relative size might change.
And we need to move around the relative positions of the legs a little bit, but this is about what we're looking like.
Here's a more in-depth version of the leg. Here's what it looks like as we actually built it. It's made out of a carbon fiber infused nylon called Onyx, printed on the Markforged. So that's how we're able to get such a nice resolution.
We can do pretty thin parts that are much stronger than regular PLA or ABS. Here's our gait timing. So we're estimating that 3 gait cycles will get us 1 body length of movement, and we need 30 body lengths, so that's 90 gait cycles total over 2 minutes. So 2 minutes divided by that 90 is 1.3 seconds per cycle is what we need to at least meet. So our conservative target will be 1 second per cycle, and here's our gait plot scaled to that time frame.
Here's all the hardware that we currently have printed and ready to go. In total, it weighs about 470 grams, and so we expect that the mass of the frame to be less than 200 grams, totaling around 670 grams. We tested the leg with 150 gram weight, and it was very successful, as we're going to see in a moment. Here's what the leg looks like under no load. You can see that we have the first mid-leg raising, at which point the bottom mid-leg lowers, followed by a swing. And so that allows us to kind of step and then drag our bot forward.
And here's loaded.
So the load weighs about 150 grams. We put it at the bottom of the foot because it was the easiest way to secure it. This is not representative of the load that the bot would actually be feeling, and it's actually a more intense version of that load, as it's applied so far away from the fixed point. We've got like lots of torque.
But we do see that the leg does hold together under this kind of stress.
And so this keeps us confident that it'll be fine under the actual load.
That's it.